Thank you very much. Can everybody hear me? It's okay. Thank you. Okay, yeah, welcome to my talk about automate monitoring with Salt and CheckMK. First, a few words about Agfa HealthCare, which is a company where we are working for. So Agfa HealthCare is an international IT provider for healthcare IT solutions. So we are in the regional scope active, which is called DACH. That means in that case, Germany, Austria, and Switzerland. And there we have three main products, which is the first one is Orbis. That is a hospital information system. It is used for surgery documentation, patient admission, and a lot of other stuff in the hospital. The next one is Impact. That's a picture archiving and communication system. It is used to store X-ray studies from an MRT or such other instance and make it available for the doctor to view it. And the third one is Hide Media. That's a content management system, especially produced for hospitals to reduce the paperwork there. And the last product, that's not a product as a software, it's a service. It's called AMS, and it's Agfa Managed Service. And we are working in that part, and I'm responsible in Agfa Managed Service for the monitoring and the automation part with my team. And Christian Dewald is one of my team member. He develops a lot of stuff. Yeah, that's that about Agfa. So the services which we are offering to our customers. So monitoring was the first where we started, where I am responsible for. But we have also an operation team. I worked also a long time in the operation team. And all these services here, which you're currently seeing, are heavily supported by Salt. So the monitoring solution, for example, will be staged by Salt. So we deliver first to customer side a Salt Syndic. That's our first system there. Then we are deploying the monitoring system via Salt, and also for the operation team, a remote access station. So a system that they can work on the customer systems. And we are also providing maintenance tasks, for example, for Oracle that are also used by our operation teams. And also for patch management, network and firewall service, there is also Salt included in a different way. So first question, who knows CheckMK? That's the monitoring solution which we are using. Oh, so many people. Interesting. Okay, fine. But if for the other, I think it was maybe 25%. So for the other ones, I will describe it a little bit. So CheckMK was founded in Munich, and it was first a plugin of Nagios. But it grows up in the years to a full independent monitoring system. And what can it deliver to us? So it's a complete monitoring system with server, network, storage monitoring, application, cloud, and container monitoring. So you can nearly every monitoring needs with this system. And in Agfa, we are using, in most of the cases, server, so the things on the left, server monitoring, network monitoring, storage monitoring, and we have for all our own application, but also like Citrix, also other applications, we use application server monitoring. Cloud monitoring is not that big in our context because the clinics are hosting most of their stuff on-premise for legal reasons. That's why cloud is not so big in our business for the moment, but I think it will switch in the future, but in the moment it's not that big. But container monitoring is also coming, so more and more applications will be delivered as containers. Okay. So what are the key features from CheckMK, what we are using? One of the key features is that it will detect automatically metrics. That is possible if you install a CheckMK agent on your server, on your minion. CheckMK is able to discover metrics like interfaces, hard disks, processes that are running, and a lot of more stuff we will see later on in the live demo. It's simple to configure. You can use a web API or can directly manage it over it's called Vato, that's the web administration tool. Yeah, and it's really scaled. You can scale it from very small environments to enterprise large environments. So that means, for example, I use it at home to monitor my air condition system and a few other things, only not more than 3 hosts, but we are also using it for large customer with thousands of servers. Some examples at Agfa, we are monitoring our network infrastructure with CheckMK. That's pretty cool because it also detects on a switch all interfaces which are running on a switch, also temperature sensors and so on. So it is possible that you have 1,000 servers or metric checks at one device. That depends on how big is your device, what it is managing. So we are managing our network monitoring with CheckMK. We have also written own application checks. For example, for that X-ray system, we have DICOM checks to call that system that it is possible to speak with this impact system. What we have also uploaded, for example, a dummy X-ray study like this Homer Simpson. We put it into this archive and then we download it and every minute and measure how fast is it possible to, you see it here. It is currently, the download is possible with 67 megabytes per second, so that you can set their thresholds, what's fast enough, or when a warning should be raised. And okay, that's a typical clinic environment. We have a lot of from them. That's one side. We have 2 DB nodes, which are clustered. You have, for example, three path storages. You have a virtual environment with VMware and a lot of network or SAN switches, which are connecting all the stuff together. So the synergy is why we are using Salt and CheckMK. So Salt, we started first with CheckMK, but then we switched to Salt. So we switching, we are using Salt as data center automation, and then we learned, okay, there are big synergies between these 2 systems because we have on one side Salt as intelligent automation. For example, you can create with Salt new via LVM or whatever. It will be automatically create new volumes because your system is running out of space. CheckMK will automatically detect the new volumes and add it to your monitoring. Salt will deliver or brings a full Python environment. If you install it, you have a Python environment on your minions. That's pretty cool because CheckMK is also written in Python and you can write your own plugins in Python. So your CheckMK plugins and run it on your minions because there is on every minion a Python environment available. That's also, we are also using Unix environment like IIX and Solaris, and also there we have a Python environment available. And what also is pretty cool, Salt delivers us a lot of asset data beside the CMDB, and we can use this asset data in CheckMK to define rules. We will see that later on in the live demo. And an absolutely must-have, both systems are supporting mostly all operating systems. So we can cover everything that we have in our bunch of, or in our portfolio. So, and both are supporting this master of masters concept. We will see that now. That's our topology at Agfa. So we have in the central data center a master of masters. So the gray lane is the Salt terminology and the green one is the CheckMK terminology. So we have in the central data center a master of masters and a CheckMK master. Then we have around about 100 hospital sites which are connected to the central data center. And in each site we have a Salt Syndic deployed. And with the Salt Syndic we are deploying also a CheckMK slave, which is also connected to the CheckMK master system. And then we have on the other side also located on-premise in the clinic, in a hospital, the host or minions which we like to monitor or to manage. And that is a bunch of operating systems like IIX, Solaris, Oracle Enterprise, Linux, Red Hat, Debian, Ubuntu. That's really one of the big challenge, to manage all these different systems. Okay, so what I will show now in a live demo is only a snippet. That's only one salt master, a CheckMK salt master and a CheckMK master, and directly connect it to a few minions. And what I like to show is how you can easily add these minions automatically to CheckMK. So you have a simple salt environment, you have a few minions connected to this environment, to your master, and then you can set up easily a CheckMK monitoring solution and connect your minions to your solution. So that's the starting point. We have a salt master, we have a few minions connected to this master. Now we have to prepare the CheckMK setup. Therefore, we have to designate one of the minions to install CheckMK on that. You can do that by deploying a container, or you can download the package that's a DAP or a RPM package and can install it also with Salt, PKG or whatever. That's not a problem. If you have it installed, we have written an own Salt execution module, which allows us to communicate from this minion with this CheckMK master, which is hosted on that minion. That's called CheckMK Web API. That's the execution module. And then we have also written an own state module to manage all the stuff around. That's called CMK manage. What we are now doing is I like to provide this grain information, the minion that is this designated MK minion. So I collect first a bunch of grains that you can define it in a pillar file. I collect them to the master, and the master provide these grains to this designated MK minion as pillar. So the grain data is available as pillar data on this minion. And from that pillar data, the state can simply create configuration, CheckMK configuration. We see it here on the right. And now CheckMK is aware of all the minions that it should monitor. But before you can start monitoring, you have to deploy first an agent on your minions, because otherwise you have no access to that. You can also do that easily by Salt, installing a package, and if the agent is installed, your minions will be listening on 6556 TCP, that's the port from the CheckMK agent, and your CheckMK master can gather the monitoring information from your minions. Now I start with the live demo, just in case. I have created some videos, but live demo is better, but we will see. Okay. We see here I have 4 minions currently in my test installation here. Hopefully every minion is reachable. Maybe it's better to switch it to, that's better. Okay. Now I have already downloaded a container. I start the CheckMK container. And if you download it, that's a one remark to that. I'm using the Salt open version here and also the CheckMK raw edition, which is also open source. So the complete stuff here is open source. We have more features if you use the enterprise version, also from Salt, but also from CheckMK. But to see the potentials, you can also have a look at this open version. Everything works fine with that also. So what I have now to do, if you have started the container, you need the initial password, which will be created for you to connect to the CheckMK side. That should be, we see it there, it should be, it was the initial, I had used it in my test before, so it was already entered there. We have now an empty monitoring site. There's no host. For the moment, it will monitor nothing. What we're doing now is I will try first to connect my Salt with the CheckMK, with this CheckMK side. that's you can orchestrate everything, but I will show it now step by step so that everybody understands what is behind. Now I execute this CheckMK web API call. The method is get all users from the monitoring system which are currently created there. But to do that, I need a CMK secret. If you set up a new instance, or if you start a Docker container or set up a new CheckMK instance, there are two default users. That is the CMK admin and also an automation user. And this automation user has a secret, and we can use this secret to communicate with this system. Hopefully that will work. So that's the first test now. Fine, it works. We see that's the return, that is the user, that is the alias. We see here also the automation secret and the admin, the CMK admin user also with the password hash. Okay, now we are ensured that we are able to communicate with the CheckMK side. Now I provide this data permanently as pillar. There's a formula behind. So if somebody like to test it afterwards, you can simply download the formula or clone the formula from GitHub or fork, whatever, and test it in your own environment if you like. So now I have to prepare. I have to add the automation secret in the pillar file. And now you see here also the tags that are the crane defaults which are provided for CheckMK, and that are you can select there nearly or simply every crane that is provided by Salt, and it will be transferred and available afterwards in the monitoring to create rules on that base. First test that really the pillars are available. We see, okay, our MK minion is now aware of our automation secret and the cranes that should be gathered. And now I start this collection of the cranes. I've written also an own execution module to do that. That works pretty fine, and also in a master of master concept. But you can also use Salt Mine to do that. That was only a solution that I have built that it definitely also work in our environment. I think that was a copy paste error. Now it gathered the data from 4 minions. Now these data is available as pillar. So we are able to add these minions and also the tags to our monitoring installation. I will execute now this state. To create the host, that's pretty fast. You can add 100 hosts in, I think, 2 seconds. That's not a problem. It takes a bit time to create this, to create the tags behind. I think that is because the web API responds not that fast in that case. Maybe it's a test site set up with a lot of virtual machines and the containers on that machine. Okay, now we see 5 tag definitions updated, tag groups added, because that's updated because there are already tags defined by CheckMK default tags, and now the state will add this new tag groups from Salt to CheckMK. And we see it has set the tags for each host. You see also to create a host, it takes only 30 milliseconds. And let us have a look now on the monitoring side. It was an empty installation. Is it still? Because now the hosts are created in our monitoring, and they're also, the grains are automatically set. Here's now a new topic. It's called salt grains, and the salt grains are now available in our monitoring. And now I will activate the monitoring. I will do that now in a web, in this web interface, but you can also do that in Salt. That's not a problem. That you can everything do by a web API call, but I think it's good to see it also how it works together. So start folder. We have 4 changes, and we see created by user automation. Activate changes of other users. I have to check this to activate this, because the automation user is another user. I'm logged in as CMK admin, so I have to enforce this. Now we see 4 minions are in the monitoring. It takes the normal check interval of CheckMK is 1 minute, so it takes a few minutes to see that every minion is online. Currently, it's only doing a ping check behind, nothing more, because it is not possible to gather more information currently from the mins, because there is no CheckMK agent installed. We will also do that via Salt now. In this Salt formula, there is also an MSI package included as blob from this CheckMK agent, and you can simply add. You have to refresh the DB info on your Windows systems, and then you can install it with the Salt PKG system. Now it will install the CheckMK agent on all our minions. Okay, that looks okay. Now we are able to discover this matrix on our Salt minions. That is the discovery check that will hopefully work now for us. And you see now here we have 18 unmonitored services on our system. I will do that. You can do that in the bulk discovery, but I will show it you only for this host in how you can add them to the monitoring. You see that are all services which are currently available. Okay, you have some security logs here currently. If you don't like to monitor some stuff, you can deactivate it, move to disabled services, or you can simply say, please monitor all this matrix for me. Monitor. So configuration will be updated behind. And now I have to activate this change. You see, it's not necessary to enforce it because we have did this change, and then it's not necessary. But that's also if you work with different users on this interface. So we have a lot of operations administrators or which have rights to modify the monitoring, then that is a security feature that you not override some configuration of your colleagues. Activate. It could be faster, but it's and now you see we have a lot of metrics which we can monitor now, and we have the only thing to configure it was to execute this state add minions to the monitoring system. I will also do now a bug discovery behind so that we have the full monitoring data available, and then I will show you how we can create rules based on this tag definitions, on this tags that we have provided from Salt here. That is the bug discovery feature. I start it now. Discovery was successful, and I have to activate it now and then should the monitoring complete. You see on the Windows minion, we had already done this discovery, so the services are kept, not added. Okay, now we see we have a lot of services. It takes a bit time that every agent is called once. But now I will create, let us have a look. I will choose the file systems as an example. You see file system monitoring, it's only 8% usage. You have also the interfaces. This guy our summary. Force it also here. There's one that is also by default. It will also check all your systemd services. There's one which was failed. I think it was not configured yet. So the KDAM services in a critical status. See the memory on the machine. But the interesting part will now the file systems. Let's have a look. I will filter it. We see all the file systems from our minions with the usage. And I will create now this rule. You can do that. I have already created a bookmark. That's a bit easier. Create a rule. Test. And I will define now 10% is critical for me, and if it is above 25, it's a critical, or let's say 20. And now I can use my salt grains as conditions. I say, okay, that's the OS finger, add a condition. I can say exactly if it exactly match one, for example, this OS finger, that rules will be effective or applies. You can also choose is one off. And then I say, okay, for Ubuntu and also for Windows, I like to have this threshold, or maybe also another, but it doesn't matter. You can define it like based on your needs. I save it, activate it. Yeah, you have to activate every change, so you have also a change log. That's good. So you can also discard changes if you see, okay, that this change makes maybe no sense, then you can discard them. Or also, if you're an admin, you can also discard changes from your colleagues if necessary. Okay. Now we have a look again on the file systems. And we see now that was the OS finger of my MK minion, and it's now in a critical state because that rule applies on that. And the same would be for the Windows minion if the check was not, there was 1 minute delay, so it was on the next time the check is running, it will also be effective. And you see it here. Critical threshold based on our salt grains is defined. What we can also do now is I can activate a process discovery. I have prepared 2 rules. I will activate them now to discover our salt minion processes. And then we have for all our minions also the processes, how many Python processes are running, how many CPU how much is the CPU consumption or the memory, and we using that also to monitor all our minions behind. And it will be create a ticket if there is something going wrong, and our operation team will tackle that. And let's have a look. Now it should discover them. 1 unmonitored services. Let us have a look. Unmonitored process, salt minion, because it was discovered, because it's running. And so you can, based on that, you can create your own rule sets and discover all services or process that you need in your monitoring. I will also activate now a bug discovery, and then we have hopefully all the salt minions in our monitoring with processes. Activate affected. There's also the state logic behind. I will show that later on. You can delete hosts and the state will automatically detect, or you can delete tags and the state will automatically modify the delta. So it creates the or it recreates the missing tags or adds the host again to your monitoring solution. Okay, let us now have a look that the minion services are available. You see the process salt minion. That is the process monitoring I have activated for the Linux-based systems, and on Windows I have monitored the Windows services of salt. You see now there are on each minion I have 3 running processes. You see the consumption of the physical memory, you see the CPU usage, and now you can create also rules behind that you raise, that it will raise a notification for you via email, via your ticket system. Or my idea is to do it maybe also in future on a salt event bus to react on that. The problem is if really the minion crashes, you have a problem that you cannot fix it with salt. But for any other thing, you can maybe build a self-healing infrastructure with that. Okay, yeah, let us show if I delete some stuff here. I remove a minion. Yes, from the monitoring. It's not necessary to activate the change. It should be also detected. I execute the state again. Oh, there was one problem with the host text currently, so that's a live demo. Get in use. I think it's there still. I have not activated. There was still a tag in use. That's a problem. So it raised an error, and it Salt will raise it up here. But you see the missing host was added. I think if I activate the changes now and execute it again, it should run without problems. Okay. So the host is recreated. So that's pretty cool. So you can manage, you can keep your complete environment in sync. So we install the minion, and if we have installed the minion, it will directly add it to your monitoring solution. That's how we use in our case, but maybe it's also interesting for you. Yeah, that's basically was my live presentation. Let us go back to the slides. So everything is available on GitHub, on Tribe29. That's a company which creates or maintains CheckMK. And yeah, there are already the Salt state and execution available. There's a detailed documentation available on GitHub, and also you can edit this formula. So it was my first formula. I think there's much space for improvement, but I think it will work. Okay, yeah, that's my collection of ideas for the future. I thought it before. Maybe it's really interesting to raise notifications from CheckMK directly on a Salt event bus and react on that. Then also maybe a pretty cool thing is to add also proxy minions, or maybe we heard it this morning, maybe also native minions to add network or maybe storage devices to that solution. And yeah, what be different, definitely an important thing is that I create unit tests to test all the stuff. Yeah, that's from my side a bit about me. Yeah, I'm working as tax as a solution architect at Agfa HealthCare, and also beside that, if there is time, I'm also available as a freelancer and consultant for automation and monitoring stuff. So thank you very much. Have you any questions about this?
Thank you, Philip. That was awesome.